Hi guys, welcome back. Today we will talk about the tone curve, which is this tool that is located below the basics in Lightroom. To describe it briefly, it is a tool that is used to adjust the brightness of an image and also to adjust its color. We learned in the previous video when we talked about the basics that you could also adjust the brightness there, but the difference with this tool is that it is more precise. And in photography or in any other arts for that matter, we love precision, because the more variables we have control over and the more control we have over them, the more different and unique our end product will look, and that can make us stand out from the rest of the creators, the photographers and the artists out there. To begin with, I would like to introduce you to the components of this tool first, and we will learn step by step everything that you need to know about it. So we have the histogram behind the curve, which is the same as the histogram on top, but doesn't move in real time. We have the curve itself, which is a line before you adjust it, and we have above this graph 5 different types of curve for adjustment, called the parametric curve, which is the current one, the point curve, then the red, green and the blue channels. The last thing to notice is this button over here, which can be used to adjust areas directly on the image. Now, in order for you to be able to understand everything about this tool, I need you to know the answer to the following question first. And that's how do the picture elements, aka the pixels, create color? Well, each single pixel is made of 3 different color sources. The first source can only produce the red color, the second only the green color, and the third only the blue color. The brightness level of each source can be adjusted individually from 0, which means no brightness at all the way up to 255, which means maximum brightness. Then the combination of the brightness levels of each of these 3 color sources is what creates all the other colors a pixel can produce. For example, if all 3 sources are at level 0, the pixel will show pitch black. If all of them are at level 255, which is the maximum, that pixel will show complete white. Since there are 256 different brightness levels, including the 0, and there are 3 color elements, rising to 156 to the power of 3 will give us a total number of the colors that a pixel can produce, which is about 16.7 million. After having explained that, now we are ready to understand that the parametric curve and the point curve adjust the brightness of all 3 color sources of each pixels at the same time, while the red channel, for example, only adjusts the red light source of each pixel, leaving the brightness of the blue and the green channel unchanged. Now, in order to understand really well how it works, we should perhaps be able to build it ourselves to a certain degree, right? This tone curve, I mean the graph. So let's do that. So I drew this little graph here just to explain exactly what the tone curve is. First I want to, I don't know if you can see this really well, but I've tried to make a 3D effect here just to draw the histogram as well, which is behind the curve. And it is behind because it doesn't use the same 2 axes as the tone curve does. For the histogram, in the bottom we have the brightness of each pixel, and then in the vertical axis we have the number of pixels with that level of brightness. But with the tone curve, the horizontal axis has the input brightness of each pixel, which starts from 0, like no brightness at all, until 255, which is the maximum brightness. And on the vertical axis then we have the output brightness, like the brightness that the pixel will have after we have adjusted it. The tone curve in the beginning looks like a line because the ratio between the input brightness and the output brightness is 1:1. It's because, think about it, if we haven't changed the brightness that the pixel has originally, then the outputs also will be the same as that. For example, if we have an input brightness of, let's say, 128 here in the middle, then the output brightness will be the same, like 188 there, and so that makes this point. If the input brightness is 0 and the then the output brightness will also be 0, so that's here. If the input brightness is like the maximum 255, then the output brightness will also be 255, and that's here. And if you connect all these dots, then you get this line which in math is like y is equal to x, but for us is then the output brightness is equal to the input brightness. And so yeah, I think this should be pretty clear now what exactly this is and what exactly you're doing with it. For example, if you increase this right here, the curve, then the input brightness of these pixels, which now was there and in the output was here, will now have a higher output brightness, and the curve should be something like this. So now that we learned all this information, we can start thinking about what kind of adjustments to make to the curve. In this photo, for example, I feel like the highlights are a bit too bright, so I will try to darken them. Using the parametric curve, the x-axis of which is separated into different regions called shadows, darks, lights and highlights, I could either go to the highlights region on the curve and then just pull it down like that, or I can use the highlights slider below the graph, which does the exact same thing. While I do so, notice the highlights of the photo getting darker and the histogram moving towards the left on real time. And also the histogram behind the curve not moving. One thing you would also do is choose the range of each region by yourself, by moving the sliders down here. By default, each region is 25% of the whole, but I can decrease the highlights, for example, up to down to 10% and increase it to the maximum of 70%. You should also notice that on the parametric curve, whenever you adjust one region, the other ones are not affected by much, but they're still affected a little bit. The parametric curve kind of sticks to its shape on all regions but the one you're trying to adjust, and that's what makes it an easier curve to work with if you are a beginner. On the point curve, on the other hand, the curve moves more freely, and that can be scary at first, but the good thing about this is that you can make much finer adjustment to many more brightness levels than you can with the parametric curve. For example, now that I pulled the highlights down on this curve, it seemed like the rest of the curve has been lowered even further, and I need to fix that. And all I need to fix that is make some other points along the curve and bring the brightness levels of those pixels exactly where I want them to be. For example, right here. I'll bring this down again. Yeah, this is not beautiful, but I'm just trying to prove a point. Notice that the parametric curve didn't solve us the problem of the overexposed exposed pixels, which we have here, which we can see on this histogram, and which are like the really bright ones. And cannot solve it at all because the extremes are fixed. Like the very bright point is like it doesn't move, and also the very dark one doesn't move. But on the parametric curve they do. So I can grab this and bring it down, and I can grab this and bring it up also a little bit, and that way I avoid overexposing and underexposing the picture, and you can see that there is a space here on the histogram. I personally think that fixing this problem as the first thing that you do, it makes your life much easier. And since we're talking about making your life easier, let me tell you how this button here works. Firstly, like, you need to click on it, and then one way to use it is by going to a place over your photo whose brightness you think needs to be changed. Click the button on that area, then pull it down or up while holding the mouse clicked. For example, if I want this to be brighter, and this is how I do it. Of course I went too much here, but you get the point. The second way that you can use this is by going to the pixels which brightness you think should stay the same, that you think it's fine, for example here, then making points, and then you can adjust the regions in between those. Under this point curve we have some standardized presets for a contrast with 3 options. which is the linear, and that's the first one that we start with. Then we have medium contrast, which is this slight S shape, which brings the highlights down and the shadows, the highlights up and the shadows down. Then we have strong contrast, which is an even more pronounced S shape. In order to achieve the opposite, like less contrast, you will need to bring the shadows up and the highlights down, like that. If you're looking to create a kind of film look that you see sometimes in some picture, it is achieved by making a point somewhere here near the bottom and then increasing the shadows. Like that, and then doing the same with the highlights, bringing them down. Like that. I think I need to solve the overexposure problem here a little bit, so just to make the picture look a bit more realistic. Yes, so that's the film look that you're searching for. And now that you know how this curve works, you can also understand the RGB channels, like the red, green and blue channels. Fairly easy because the principles are the same, like I mentioned earlier. The only difference is that you will be adjusting only one color element at a time. So if you push the red curve up, for example, you get a red effect on your photo. And if you pull it down, you let the green and blue colors take over, which together give the photo a cyan color. Cyan is then called the opposite of red, and you can see this color also like in the graph represented in there. The same way, for example, magenta is the opposite of the green and yellow is the opposite of the blue, because, for example, yellow is the mixture of red and green, and if you lower the blues, then you let more red and green combined together, so that means more yellow. What I can do with the RGB curves, since my photo looks a bit like too cold, is to add some yellow and red, because they are like complementary to the cold colors like blue and green. I do that by going to the red color and increasing the black and white points of this curve just a little bit, and also like on the blue color, like I already did a little bit by decreasing these extremes and the middle. If you found this video helpful, consider giving it a like and subscribe to the channel so that you don't miss any of the upcoming videos. If there is anything you would like to add to this topic, or if you have any other topic you would really want to know more about, just feel free to comment that down below, and thank you for staying till the end. I'll see you next time. Bye bye.